Okay, the population, 26. The population millions of Suzhou, China can be modeled by the function P of t equals 1.1 times 1.066 quantity to the t. This is an exponential function. So there's 1.1 million people to start with, and they grow at 6.6% for every period t, where t represents the number of years after 1990. And t is between 0 to 25. Which of the following equations best models the population in Suzhou, where n represents the number of years after 1995, not 90, and n is between 0 and 25. So if I want the number of years after 1995, what the population would be, in terms of n, so if we look in, every exponential is a function of n, and it's all raised to the n powers. So what do we know about this? We know t is the years since 1990, n is the years since 95, so t equals n plus 5. So think about it. If the year were 2000, since 95, that would be 5 years. 5 plus 5 is 10 years, which is exactly how many years it would be since 1990. Okay, now I can run with this. The equation originally of 1.1 times 1.066 to the t represents the population. Well, now I can rewrite that as 1.1 times 1.066. I'll substitute n plus 5 in for t. That's to the n plus 5. Do I have an answer like that? No. This kind of looks like it be, but that's wrong. It's n minus 5. Now I just need to apply my exponent laws. If I'm adding exponents, that means I can multiply exponents of the same base. That's my product rule. So that means I could rewrite this as 1.1 times 1.066 to the n power times 1.066, the same base, to the 5 power. That's the same thing. Do I see that answer anywhere? I do. C, they reverse the order of the n's and the 5's, but multiplication is commutative. I can change the order. So C is the same answer as what I would expect to have for the population expressed as a function of n. That's the correct answer for 26. 27, x squared plus 6x plus c equals 0. So again, this looks like it's solved for the constant. In the given equation, c is a constant. The equation has two distinct real solutions. Well, anytime you see that, we know it's a quadratic, which it clearly is in standard form. We know the discriminant must be greater than 0 in order to have two distinct roots. So my discriminant is going to be b squared minus 4ac, and that must be greater than 0. Which statement about the value of c must be true? So if we plug in our discriminant, we could create an inequality that will hopefully tell us something about c. So b squared, b is the coefficient of x, that's 6 squared, minus 4, a is the leading coefficient of x squared, not shown, but it's 1, times c. We'll keep c as the variable because that's what we want to figure out or find some kind of solution for. Okay, that's greater than 0. So 36 minus 4c is greater than 0. I could say, therefore, 4c, 36, adding 4c to both sides, is greater than, 36 is greater than plus 4c. Divide through by 4 on both sides. 9 is greater than c, or c is less than 4. So, or c is less than 9, not 4, sorry. C is less than 9. D is the correct answer. And again, if c were much bigger, we know that makes our discriminant smaller and it would go negative. It wouldn't have two real roots, just as a check. So we want to limit the value of c. The idea is that c is greater than, these are not going to be correct, right? So conceptually, D is the correct answer. C is less than 9. 28. A procedure allows a researcher to determine the concentration of glucose in micrograms per milliliter in a soil sample by measuring the absorbance X at a specific wavelength of light, which is our y value. The scatter plot shows this relation for 5 soil samples. Okay, that's the 5 dots on our graph. Which equation is the most appropriate linear model? What's a pretty good linear model? I can kind of even just sketch a quick line of best fit. It looks like it passes through 0, 0. So our constant, or our b value, the y-intercept, should be close to 0. It's not going to be any of these with a 10 or a 90. It's going to be one of these, 1.5 or 1.5. Now I just need to figure out, is the slope 90 or 10x? Well, let's take a look. Again, be very careful what the grid lines suggest. I go 10 up to go 0.1 over. Well, that's basically 10 divided by 0.1 is roughly a slope of 100. Well, it's not going to be 10 as the slope, 10x. It's going to be the answer with 90x, which is pretty close to 100. Now again, maybe I'm taking too close a data to my origin. Let's go out to 0.5. 0.5 probably fits something less than 50, which indicates it's less than 50 for a half change. It's less than 90, so I should be less than 100, I'm sorry, which 90 is less than 100. A is the correct answer for number 28.